Yes, now it's time for next speaker. His name is Pandur, ladies and gentlemen. Hi, welcome. You've been with the demo scene for a long, long time, and now you're coming back with something fairly new.
Yeah, so Cables is our WebGL editor tool, visual programming toolkit.
So I heard about OpenGL. It's like graphics 3D, and so you moved it. This is moving it to web, right? So you can work with it in browser.
Yeah, so WebGL is the OpenGL API on the web. So, and what's awesome about it is that you can just send someone a URL and you can watch a demo, for example, or you can watch it on your phone and do not download something. So that's the main difference.
And it's I don't need to download anything. So like JavaScript or anything, it just works.
With Cables, yeah, you don't need to program. You don't need to program one line of code and can
even
build
in like
it.
In my browser, Firefox, Chrome, anything can do that.
Yeah,
it's included, no download. And so what does basically you invented Cables? You're the one who programmed it. You're the one who did it.
Yeah, basically I started it, and now we are a few people working on it, and yeah, it's evolving and. Yeah.
And what does Cables do? It's like makes the programming easier or faster?
So yeah, it's making like prototyping a lot of faster, and also like people who do not program, like for example motion designer, who have a basic technical understanding, can also program, but they don't know that, but they are actually programming, and they can do it without like caring for a semicolon at the end of the line and stuff.
These are programmers. These people are really about clean code and everything. Isn't this like contradicted? Like it's fast prototyping. Well, it means like you fucking load all the libraries and you load of shit and then you just put it in and whatever. If I use it or I don't.
Well, you can open a code editor and write code in there. And this is what I do all the time. And the same with normal coding. Is like you have a lot of modules. You always copy paste back into your code or like reuse them. And this is basically what the visual programming is about. You can reuse stuff really good. So it's not about like, oh, I don't want to type, but it's more like do it faster and type. And, yeah.
And does it come? Did you use the things you learn in demo scene and then saving space, saving memory, and did you use this, or you just said like fuck it, we have fast computers, I don't care?
No, I mean in the web you want everything to be small, so it's not like it's not for 4K or 64K, but it's really small, and it's also when you export what you've done, it's only contains the code that you actually use. So it's not a huge library you have to download all the time, but yeah, it's like the smallest size is like 30K or something.
So looking forward to it, because you're one of really not many people who really made some money at demo scene, which is really great. So please give your hands up for Pandur, ladies and gentlemen.
Thanks. So before I get into Cables, the editor itself, I want to show you a demo we did with it. That was released at Deadline in October last year. And, well, yeah, you can see what's possible with Cables. This demo doesn't contain any special code, so if you log into Cables and you learn how to use it, you can do this demo without writing a line of code, because it's just, everything is available to the user who uses Cables. But yeah, we will see the demo first. Thank you very much. So another project I want to show you before I show you cables itself is this thing. We developed it with artist Rafik Anadol, which is an artist in LA, and the idea was to collect public APIs from around Los Angeles. For example, those are weather stations, the little dots, and the circles are tectonic activities or little quakes or something. And yeah, you can see them on the map, and you can navigate it and scroll in, for example, and then you see Los Angeles, and those little dots, for example, are building data from OpenStreetMap, and the blue dots are tweets or Twitter activities. All this data is from the last 48 hours, and you see where people were active and tweeted, and those lines you see sometimes. Sorry. Those lines are tweets that when people communicate to each other on Twitter, they write this with a little @ sign, and we have both geo coordinates of both people, so we can draw a line between them where they send the tweet to. And yeah, you can watch where stuff happens. For example, this little circle here is a stadium, and yeah, there's a lot of activity in this circle. And yeah, you can also zoom in here and have an abstract view of the data. And you can also open this website with your phone, and you have this view on your phone, and you can look around with your phone like in an augmented reality application. So Cables is not only for demos, but also for projects like this, like getting APIs and visualizing data and showing data, basically. So, okay. Thanks. Another thing we use Cables for is Evoke. This is the main stage of Evoke. And at Evoke we use Partymeister for people uploading demos and contributions and voting and all that stuff. And we don't use the renderer of Partymeister, but we use Cables for it. So this screen currently, here's a production, and this screen shows which production is shown. And Cables does display that and gets the data from Partymeister and displays it, and we always, for us it's very important that this is animated and has good design and stuff like this. And also all the advertising screens on the main screen and the prize giving in the end, this is all done with Cables. So this is really good for us because, for example, many times we do the invitation ourselves for Evoke, and we do it in Cables, and then we can take the invitation and use this for our party system and display all the animations from the demo as backgrounds for the slides, for the graphical slides. And yeah, this is another use case of Cables for us. So, okay, let's go to Cables. So, right now, Cables is invite only. So, if you guys want log in, just come to me and give me your email address, and then I will invite you. So, we have some users already in there. They test it and they can use it. There are also some people who made demos with it. And yeah, just go there if you want and ask us stuff. We have a Slack channel where you can chat with us, and yeah, you can just use it then. So when you open the website, you see something like this. And this is, we call it the community part of Cables. You can see people are active there and making their patches, we call those projects, making the patches public so other people can have a look at them. A bit like YouTube or something, and you can open it, and you see already the WebGL thing. So this is most times it's interactive, and yeah, you can see this was done by Bagoof, and yeah, you can browse the stuff from other people basically, and all the stuff that is public there, all the examples, you can just click Open Editor, and then you can inspect it. How is it done? So this is the main cables editor thing, visual programming language, and you can just look how people did this and can copy paste stuff out of it, and or remix it, or just play around with it and learn from playing around. There's also this is somehow broken on Windows, I guess, and there's a big list of examples. You can have a look at them. This is somehow broken, but yeah, it's really beta and in development. You can look at these examples and open them and look how they are done. For example, like this. So let's build a little patch. So I click on Create, and I can start. So this is what cables looks like. Here the big area is the patch field, where we can put operators. They look like this, so we call them ops, like operators. They are little modules, like a function in your code, that they do one thing, and only one thing they should do. And so this is, for example, the main loop. So this thing is executing everything under it 60 times per second, or tries to do that, so that you can do smooth animations, for example. So I can create another operator below it, for example, circle. And now it's drawing a circle. And in cables, the flow of execution and data is from top to bottom. So the main loop calls the circle, and the circle draws itself basically on the screen. So what I did here was to link those two operators. And you see those little rectangles here, those are called ports in cables. And on the top you have input ports, and on the bottom you have output ports. So when I click the circle, it has a lot of ports here, and you see the same ports here. So the first one is like segments, and I can just change it by typing a number in, and you see the circle gets more edgy. And there's, for example, an inner radius or percent, how much of the circle should be drawn. And yeah, you can play around with it a lot. And so these are those ports. We'll come back to that later. So let's do a nice circle again. So to transform that circle, or like I want to move that circle around on the screen. So I want to create an operator that does that. And for example, there's the transform op. So this is our library where you can search for operators. And for example, when I search for transform, you see the transform operators at the top, and there are a lot of other transform operators. I think we have now like 900 operators or something. So I press return, I press enter, and the transform op is now inserted between those two ops. So you see a little gizmo here, and you can click it and you can move the circle around. Also, you see that number now changed. You can also drag this number around and move the circle around. So next thing I want to do is like to make this, to bring in a bit color. So I will add a material. So there's, for example, when you search here for material, you see there are a lot of materials that I want to use the basic material, which is quite basic. You can change the color of it, of the circle. And yeah, that's what that does. So when I add another operator here, for example, a rectangle, let's make that a bit smaller. You see there's now a rectangle on the screen. And when I transform, change the transform again, it will move both objects at the same time. And I now can put in another transform before the rectangle, and now I can only move the rectangle. So this is the hierarchy of the rendering. So when I change the transform of the first transform, it will transform both meshes, basically. So in Cables, you can press F, and you see how the order of things is. So at first, the color is set, then the transform will be done, the first one, then the circle is drawn, and then the second transform is done, and then the rectangle is done. Same thing works for the material. So when I add another basic material at this point, I can change the color of the rectangle only. So yeah. So next thing we want to do is like to animate the circle a bit. There are a lot of animation ops, for example, sign anim. So this one also needs to be connected to the main loop or to the main execution path. And you can see here that the numbers are all the time changing. This is because I connected it to the main loop. So when I cut the connection, you see the number is not changing anymore because it doesn't get updated. So I will connect it back to the main loop, and you see the numbers updated. You can also hover this, and then you see the sine curve, the actual. So we can now take this output value and connect it, for example, to position X, and then it will move the circle in the end. And we can now like play around with the parameters, like make it really fast or make it wider. And like this, you can animate it. So yeah. So there are a lot of animation ops. For example, we have some random animation. Let's add 2 of them. On the y-axis also. And now the circle moves around randomly, and we can look at those parameters here and like change the duration so it's really fast. And yeah, you can easily animate stuff with that. You can also use mathematical ops, for example, multiply to change the range of the numbers. For example, I can multiply this random animation by 2, and it moves faster now. And yeah, you can basically calculate numbers with those operators there. So sometimes you don't want just animations like this, but you want a bit interactivity and move the circle around with your mouse, for example. And for this, we can use the mouse operator. And say normalize, and then I can move the circle around with my mouse. So the mouse operator outputs the position of my mouse, and it will translate to my mouse, basically. So what else do we have? Do we have some more transform ops? For example, what we use a lot also for demos is random cluster. So this one actually transforms everything below into a random position. And you can change the number here. You can say like only 10 of them or 100 circles, and it will draw 100 circles at random positions. And you can see when you press F again, you see the data flow, and it's much bigger here, and there's much more going on. This is because this is called 100 times per frame now, so it draws 100 circles. So, and the random cluster, for example, gives us a random number, and we can again add material down here and connect, for example, the green channel to a random number, and then then every circle has a different number. Okay, let me check my list shortly. So yeah, so these were like 2-dimensional shapes. We also have 3-dimensional shapes, like for example a cube. So this cube I can rotate here, and then you see it's actually in 3D. But the basic material is kind of boring because it just draws one color. So there's, for example, it's the wrong one. Fong material. So now the cube is shaded and gets light. So when I rotate it, you see there's light. So there are a lot more ops. For example, sphere. This draws a sphere, basically. And again, I can move this around. And now for Fong material, we have light, but we don't see a light op right now, but this is like the default lighting. But I can, for example, add a point light here and move that light around. So, like this. So right now this is really hard to navigate. So there's, for example, an operator which is called orbit controls. I can insert before those meshes, and now I can use the mouse and rotate around and zoom in, and then it gets much easier to navigate or like to position that light. So, so the light is here. Now it's much easier to position it for this, like this. So those are really basic shapes. We have a lot of them in cables, but you can also import 3D meshes. So I have an OBJ file here, for example, and I can just take it and drag it into cables, and then it gets uploaded. And I can use an operator called JSON 3D mesh. So the OBJ file is being converted to a JSON file, which is easier to read for browsers. And I can, I will remove the cube. Okay. Oh, yeah. So you can select the file now, and then you can select the 3D file I uploaded. And now I have this OBJ file in here, exactly working like the cube, and you can set the scale here, and yeah, you imported an OBJ file. So the same principle works also for images and music and videos. For example, I can take this image file and drop it here, and it will create this operator with the image in. And now this will look crappy, but I will do it. I will connect the texture to the basic material, and Yeah. Ah, yeah. So we don't see this image now because Phong material overrides it. So when I remove Phong material, we see this image on the mesh, but the mesh doesn't have really good texture coordinates. So I will create a rectangle. So you see the image is now on the rectangle. And you can rotate it around or make it bigger. So we saw how animations work, and we like colorize stuff. Now I want to show you how for a demo you need a timeline. Like in the first 3 seconds there's this scene, in the second part there's this scene, and so on. So I will remove that stuff right now, and I will create an operator called time sequence. So this one is huge. So it has a lot of outputs, and I will now create a rectangle in the first output, and we see it, and the circle on the second output, and we don't see it. So when we look at the input ports, you see a current here, and this is set to 0, so it will render the first output. So we can press F again, and we see only the first output is rendered and not the second one. So I can now say render the second one when I change the index to 1, and you see it's now rendering the circle. And yeah, I will create another one, for example, clear color, and change the output to 2. And make it red, and then you see our third scene is just a red color. So I can change the number here to switch between those scenes. So now we want to animate this. The most simple animation you have is a timer, which just counts the time the op is running. So I will insert a timer. So you will see the number is increasing all the time. So I can connect this to the time sequence. And it will now show the scene where the number is. So in the first second, it will show the first output. In the second second, it will show circle, and so on. But sure, the number is way too high now. So for example, we can add a modulo op. So this one takes the number from the timer, and you can set the second number to 3. So the modulo op will always give you a number between 0 and 3. And so we now have like a sequence of our scenes animated after each other. So, but for a demo, this wouldn't work, but because every scene has a different length and stuff. So there's another option. We can animate this part. So I can click on this little time icon here, and I get a timeline, like in a video cutting program like After Effects or something. And I can move this time, so this cursor around, and I will change the time with it. So I can set the cursor here and change the value to 1, and you see there's now a line going up to the new number, and I can go to this frame and add another number, and to this and set another number. So when you move the cursor, the value of the port is, so I can press play, and the value of the port is animated. So in this situation, we don't want the interpolation so that there's a smooth number between those points, but we want absolute values. So I can select all the operators and say they are now absolute numbers. So now you see the scene will change at this point. And yeah, so when I press play, you see we have a little script going on. So, and this is like the main thing in a demo. When we do a demo with cables, we time the main timeline we use this time sequence for. And I want to show you the demo in cables. So this is a bit chaotic because it's not really cleaned up or anything. And I think there's even an error message, but let's have a look at it. This takes a bit to load, so yeah, we ignore that. So now it loaded the patch, and now it's loading all the assets of the demo. But yeah, that was really quick. So this is the patch of that demo. It's much bigger actually because we use sub patches. This is, for example, a sub patch, and I can double click it, and I can go in, and you see there's a whole other patch in this sub patch. So those sub patches here, sorry, it's really not cleaned up. Those sub patches are basically the scenes of our demo we did. And when I click the time sequence, you see this is our main script of our demo. So this is the first scene you saw, this is the second one, and you can just scrub through the demo and change those numbers. And so when I press play, you also hear the sound and can just scrub through the demo. And yeah, when I take this, I can just change the position of that scene or the length of that scene. And yeah, so yeah, this is our demo. So here in this part, all the little parts of the demo are played. I think this part this is the audio player and the syncing stuff. And on the right we have the main post-processing stuff. So I can just, I don't really remember what's going on here, but for example, I can press F and see what's going on. And for example, I can use this. No. Yeah, I don't know. I just change a parameter here, and you see the whole demo now looks like this. And you can, on the fly, change this stuff. For example, I can just add invert, and then the whole demo is inverted. And yeah, so that's the demo. Let me check my list again. So yeah, so in the demo, in the hold-on demo, there's a lot of post-processing going on. And so post-processing is done on 2D, on like a 2D image. What we did until now was like we moved meshes in 3D and only changed the position in 3D and changed the material of that mesh, but we want, for post-processing, you want to change the whole image. You want to alter the image or make it brighter or darker or something. And this can also be done in cables. Let me shortly build a new scene again. So we have this scene with random cubes. Let's make a really simple animation so that they rotate. I will add a transform and just take the rotation parameter and connect it to a timer, so it's just endlessly rotating now. And I can connect it to another axis too. So we have a nice animation going on. And so now so this is my 3D scene, and now I want to convert this to an image and put some effects on it, like in Photoshop. So I will create an operator render to texture. So this one will do everything what's below it, like the other ones, and render it to texture. So my rendering output now is black because the 3D scene is in a texture and not drawn on the screen. And I can show it again, for example, with a full screen rectangle. So this thing basically draws a rectangle over the whole screen. And now I can connect the render to texture to the full screen rectangle, and then it looks like before, basically. So what we now want to do is like change this image. So let me just explain that again. So what's going on now? The main loop goes into the sequence. And the sequence is just like, it's just executing everything under it. So at first, it's executing the render to texture. And this is drawing all the stuff like the cube random cluster. In the end, this render to texture creates an image and sets the image to the full screen rectangle. And after that, the full screen rectangle is drawn on the screen. So now we can go in between and create an op called image compose. So image compose creates a new texture that I can draw with the full screen rectangle. So into this texture, I want to draw an image, and I will take the image from the render to texture. So this is a bit confusing, it still looks the same, but now in the image compose, I can apply effects to the texture. For example, like a blur. So I can add the blur operator, and then now I can animate a blur onto the image. Or, for example, like chromatic aberration, like add a bit of this red-blue shift on the scene, or let's add some white noise to it, and a bit less, like this. And yet, so when you search for texture effects, those kind of effects are called texture effects. And when you search for it, you can see them. For example, there's like brightness, contrast. Like in Photoshop, you can set the contrast of the image and the brightness, and really change the look of the basic scene we have there. So there's also like a vignette, for example. So it already looks a bit like a demo. And yeah, so with this technique, you can do a lot of powerful stuff. Like, for example, I can render a noise texture and use this to deform this texture. Or, for example, I can create another image compose and draw the same image from the beginning. You can always click on those ops, and you see on the right side, you see the original texture, so the unaltered texture. So I will create another one. You can see here what I'm doing. And I will, for example, add Luma key. So this op only removes all the pixels that are not as bright as this value, for example. So only the brightest parts are shown. And then I will blur this. So I have a blurred version of the image. And then in our second render pass here, which is producing this image, I will create another draw image. and this one, and now we draw the blurred version. So now we only see the blurred version, but we can change the amount, how much we want to draw this. And also we can choose a blend mode, also like layers in Photoshop. I can say, for example, add. So now we created a nice blur. I will disconnect this so we see only the blur. So we created a blur of the scene. So it's glowing, which is also very important for demos. And yeah, you can choose other blend modes like, I don't know, difference or something, and you get interesting effects out of this. You can also change the position of the image and stuff like this, and this is really, really handy for post-processing stuff. So another thing you can do with image compose is, for example, glitches, which we did a lot in the Holon demo, 2D glitches, just like destroy the 2D image we are showing. And for this, we create another texture. Let me fix that blur first. So we create another texture, and when you search for noise, you can see there are a lot of texture effects, like Perlin noise, value noise, which is like more pixelized, and simplex noise, and I will use the Perlin noise now. So now I create a texture which contains this noise on the right side down there, and I can again use, for example, brightness contrast to change this texture. So I want to make it a bit harder, like this, for example. And the Perlin noise also have a lot of options here, like you can scale the noise, or you can add a scrolling to it. And so now we have a nice noise texture. So let me change the size of it. By default, this is always the viewport size, so the size of the renderer. And but no, actually, this is okay. So and now there's a texture effect operator which we want to apply on our main image, which is called pixel displacement. And this one takes another texture, and I can change. So I can shift those numbers, and then it will basically glitch this image. So it will look up the texture from another position, and yeah, you can produce interesting effects with this. So let's make this like this, and then yeah, you see you can do interesting effects with it. And also I can, so the movement we see right now is all only produced by the timer we set in the beginning. So when I remove this timer, so you see there's no movement. I want to show you something, so I will remove this and go back to the Perlin noise. And now I can, for example, create a timer and connect this to the X position of the noise, and then you see it moves from left to the right, and I can connect it to the Y, and then the noise moves in this direction. And so yeah, you can tweak a lot of parameters there and get interesting effects out of it. Okay, so I don't know how late it is already. I think, okay. So now let's say we finished our demo and we want to use it. You can just click Patch and click Export. And now it will compile a version from the stuff we did here, and you can just download it, and you get a zip file which contains static HTML and JavaScript code to run this demo. So you can now put it on a web server on your website or something, and people can have a look at it. So this is not like a cloud solution or something. You really get the files you did, and you have those files. And yeah, you can put it, for example, in an Electron package and submit it at a demo party. And yeah, you have your demo, or you put it on your website to make a nice background effect or something. So yeah, this is how we do the demos. In the end, we click this export, and then we have static files. I cannot show you right now. I cannot click it because you need a web server because of security stuff, but you can just upload it somewhere or run it in an Electron environment, and then you see this. You can see your demo. Okay. So one other thing I really want to show you shortly is how to code in cables. So until now, we only used ops that were already there, but you can also create your own ops. And so actually, all the core of cables and all the operators will be open source. You can always click on an operator and show and say view code, and then you see the code of the operator. So for example, if you think the cube operator is shitty, you want a better one or a different one, you can just copy this code and create a new operator. So let's do this. So I will enter Demobit, for example. So this operator is not found, so I can create this one. So it creates a namespace, user Pandur Demobit, and I can create it, and it opens the code editor. And now I can search for Demobit, and I see there's a new operator called Demobit, and I can create it. So now we have an operator that has no ports actually. So let's write a port. So I will create a port called number 1. Like this, and now I can click save and click execute, and you see the operator got a port now. So here's a number input, and I can just type a number here. So now I can create an output value port, calling it result. And again, you see the port down here. So now I want to do something with number 1 when this value changes. So I can add change listener here. So this is an anonymous function which is called every time the number changes. So let's just take this number. So like this, I get the value, and then multiply it by 2. And yeah, let's call it R. Like this. And now I say result, our output port, set R, and execute it. So when I now change this number, nothing happens. So why is that? Does anyone see an error? Okay, this is strange. Yeah, usually you should see the double the value out there, but I don't really see an error right now. It is on change. like this. So, yeah, thank you very much. Very good. So, now you see we entered 2 and we get a 4 out. And yeah, every number I put in, you get the double the value out. So yeah, this is the basic version of how you code operators in cables. And yeah. So I think that's it. Do you have any questions, or do we have still time? I think we are already over the time. No one's here, so do you have any questions? Yeah. Pardon? Yeah. So let me see. So for music, we use web audio, and there's also FFT function for web audio you can use. But I don't know if I have a working example right now. But yeah, but in the end, this is possible, yes. And for Hold On, we used another approach. We load. So the musician Ronnie gave us a MIDI file of his track, and we parsed this MIDI file to JSON. There's an npm package for that there, and we parsed it to JSON and loaded the MIDI file, and we built the sync with the MIDI file. Yeah, so that's possible. So yeah, guys, if you have any questions, just come to me. And if you want to join, come here and write your email down, or come to me and give me your email, and I will invite you if you want to try it. And yeah, thank you very much.